Hi everyone. Today let's discuss about machine coding on what are different design patterns and how to approach a machine coding problem. So when a company is asking you to implement a small application within 1 hour, 2 hours or 3 hours, they are expecting uh, they are expecting you to test your design pattern and your coding style and how modular your code is and how easy to you to test it, right? So before before attempting a low-level design or machine coding question, you need to understand some basic design patterns that are very helpful here. So, one famous design pattern which can be used in most of the machine coding is factory pattern. So, I follow the refactoring.guru website where they explain all the design patterns in a very intuitive way. So, let us say I will give the links to this question links to this design pattern in my description. So let me take an example and explain factory pattern. So let us say we are designing a vehicle rental system and we need to create an object for a vehicle, right? So now the vehicles can be of different types, like it can be a car, it can be a truck, it can be a bike, and so on, right? So how to define class diagram for a vehicle so that it is easy to create an object and queue it. So one obvious way is create a vehicle base type and have car, truck and bike inherit from the vehicle, right? Car, truck and then bike. So why did we choose inheritance? For example, every vehicle will have a vehicle number. So why should we keep vehicle number attribute in the children? So we can directly keep vehicle number in the base class. Every vehicle will also have a color, right? Now, all the common attributes can be moved to parent class and we can reduce the redundancy of attributes and functionality of the object. So, this way, I can model a class diagram for vehicle, car, truck, bike, and so on. Now, whenever you want to create a new object for a vehicle, how do you do it? Right? Maybe something like def space get vehicle. Here, you do something like vehicle, right? This get vehicle creates a vehicle object. But what if you want to create a car, truck, and bike? Now you take a type variable as a parameter, and if type is double equal to 1, then return car. If type is double equal to 2, return truck, and so on. So what is the advantage of implementing this way? Wherever the code where you want to use vehicle, right? You can do something like get underscore vehicle. In this way, this is the application code, guys. This is the application code. Yeah, this is the application code. This need not know what is the type of the vehicle. In future, whenever you want to add a new vehicle type, you need not change the application code at all. You just need to change this function wherever you are creating a new object. This way, The place where we are creating the object and using the object is different, and they are modular as well. Whenever we create a new vehicle type or remove a vehicle type, you need not touch the application type at all. Here, you can directly say something like that. Now, with respect to the vehicle type, it will automatically application code is independent and can run. So this pattern is called factory pattern, where we are abstracting out the object creation to a separate class or a function, and that function creates a new object based on a parameter. This is the factory pattern. Now I will take an example and explain it. For example, let us say we are creating a parking lot machine coding project. Now in parking lot we will have different types of vehicles coming in and taking the slot, right? So yeah, we will have different vehicle as the base class, and we can have we can use factor pattern here. For example, in the question, if they say the vehicle can have different types of colors and colors can be added or removed. So now what you can do is you can create a color base class and have black color, blue color, white color inherit from the color base class, and have a color factory, something like this, where if the string value of the color is white, you create a new object for white color, or black and blue color, and by default have the white color. Now every vehicle will have a color, right? Whenever a vehicle is created, you can just pass the color object, and it need not know what is the type of the color, whether it is blue color, white color, and so on. So this way, vehicle will just have a color object. It need not know what is the type of the color, but we are creating a factory to create a new color. So factory pattern is the most important design pattern which will be used in most of the machine coding projects. Next one is, before going to the next one, I will also give one more example of factory pattern where, for example, in parking lot, if the question is to take input as a string, and depending on the string, you need to execute it. For example, if there is a command string called book slot so and so for this vehicle, now we need to create different commands, right? So what we can do is we can have a base command, and have a virtual method called run. Virtual method is nothing but this is an interface, and all the children should implement this method. For example, if there is a free slot command, means in the string whenever someone says free, and then so on so slot should be free. So this will inherit from base command executor and also implement run. Now we have different types of command, right? Search command, status command, book slot, and so on in parking lot. How do you create new command that can be given to executor factory? So you can see, right? You take an input from command line or anywhere, and if the command is so and so, you create a new command out of it. How you are creating a command is taken care by factory method, factory object. So in this way, we have a bunch of commands, different types of commands, and depending on the string input, we'll create appropriate command. So this is where I have used factory pattern for creating color and for creating commands in parking lot. Okay. So what can be other design patterns that we can use? Inheritance is very important in any machine code now. For example, in the current parking lot, if the question is to take input from command line, and the question also mentions that it should be modular to take input from network or anything. So what you can do is you create an interface out of it. So in machine coding, you have to use interfaces everywhere. So interfaces should depend on interfaces. They should not depend on concrete methods or concrete objects. Now, you create an interface for input mode which implements a take input. Now, if at all the input is from console, this is the class. This class inherits input and also overrides or implements take input. So if you can see that whenever you are taking input from console, you are just doing a scene.getLine and then return. Now in future, if you want to take input from network, you can say network input mode and so on. So you need to use interfaces everywhere and make it modular. So similarly for output, whenever there is output class, there is an output interface and every output should implement this print method. Console printer implements print and outputs it to console. If at all there is a file printer, it will inherit from printer and implement the print method. So every module. So in parking lot we have input, output. There are a bunch of exceptions. There are commands. There are models and there are different components. Right? Every component should have an interface, and if at all now input is depending on some model, they should depend on their interfaces. For example, there is a search interface. Search interface what it provides is it takes input a color and searches vehicle based on the color. Like if at all if you want to search in parking lot based on black vehicle, the search interface provides this functionality. Now search interface needs to know what are different vehicles and slots in a parking lot, right? For that, it needs to take a repository input. So if let us go to repository. So repository is nothing but a database. In machine coding, everyone will ask you to use an in-memory database only. So what you can do is you create an interface for database like add entity, update entity, and get entities. Now you create a memory repository which inherits the base repository and create a slot repository. So a parking lot will have a bunch of slots, right? Every slot can have a vehicle or it can be free. Now, whenever a slot has a vehicle, you need to store it somewhere. For that, you create an in-memory database and implement it. For example, you can use an ordered map of string and base model, and this database need not know what it is storing. For example, it can store a slot, it can store a vehicle, and so on. Base model, it there is a base model, it just gets an identity. It is inherited. It is inherited by vehicle, and also it is inherited by slot. So to simplify, what I created is I created a repository component. It acts as a database for me, and then I have used it to store slots. Why did I design it this way? Because I created an interface. In future, I can just have a SQL repository class and then inherit it wherever you are using. Like for example, search search component was depending on the repository, right? It it need not it need not depend on whether it is a memory repository or whether it is a SQL repository, right? So for now it is written as because of the time crunch I have written memory, but I can put it as a interface and then I can use it in search. So whenever one component is relying on other component, they can just rely on the interfaces and the underlying implementation can be changed and other components may not be changed accordingly. So what did we learn till now? So we have a fractal pattern for creating different types of objects. We have interfaces for every component, and every component should depend only on the other component's interface. Like maybe okay, this is easy. So I have created a search interface to provide these functionalities, right? So we would be using it in the search command. So if you see search command, it takes yeah, it takes the detail. So if you see, it creates an interface object like interface pointer, and if at all in future we change the implementation or create a different object for search interface, the search command need not be changed. Okay, then so basically every to divide the question into different components. Every component should have interfaces. Interfaces should depend on only interfaces of other components and use command, use factory pattern. One more next pattern that is important is strategy. So let us see strategy. So you can think of strategy as an algorithm. So if at all your code is depending on an algorithm to choose something, right? For example, in parking lot, I need to choose a particular slot for a new vehicle if they want to park. Now, how can I choose the particular slot? There can be different strategies, like closest strategy, maybe farthest strategy. Maybe each slot has different prices. Cheapest strategy. Something like that, right? So what we need to do is we need to have a strategy component and have an interface. What that interface should provide is whenever you evoke get free slot, it returns a free slot for us. This is what every slot strategy should implement. For example, there is a closest slot strategy which implements slot strategy, right? What it does is it takes the repository as input, and depending on the slot, it does a we can just check the first free slot and return because it is the closest strategy implementation. If at all there is a farthest strategy, instead of doing a for loop from start to end, I will do from end to start and so on. What is the advantage of keeping the strategy separate? It is useful because whenever you have a service and needs to get a book free slot, whenever someone says get a free slot, what you can do is you need to take the strategy as input here, slot strategy. Here, if you see, you are taking interface as input. We are never taking closure strategy as input at all here. We just take a interface here, interface pointer, and use it this way. First, with this interface, just get the free slot and book it. So, in future, if you want to change the interface, like change the strategy, you need not change the application code of how you are getting and how you are booking it. You just should be able to add a new strategy in this component and inherit it. And then if you see in the book strategy, we are taking the strategy pointer as input. This is one more pattern like dependency injection. Whenever you are creating an object for book slot command, it takes all the required parameters in the constructor itself. Constructor means where the object is created. This way, you are injecting the dependencies and they do not know what is the dependency, like actual implementation for it. Wherever you are creating an object for this one, let us say you would be creating in factory based on the command, right? Here, if at all right now there is only book space, slot number space, vehicle number, right? In future, if you say book space, cheapest space, vehicle number, and so on. So what you can do is, if it is cheapest, then appropriately send the correct strategy. So wherever you are creating an object for booking a command, there you can send the strategy object, and the internal implementation may not know what is the kind of strategy. This is one of the important commands. Then so we can go through some of the components that I can use. Any machine coding project will have a repository to store in memory objects, We can have strategy depending on the question. What are we deciding? If we are deciding something, we can put it in different components. In this question, if at all there is such functionality based on the color or vehicle number, I have created a new component. Then there will be a service, actual service that implements. For example, in parking lot, what it does is it just needs to run. It needs to take input from command line and run it. So what it does is in run, it just takes from the input command, and then unless it is quit, it tries to get a command out of it, and then it creates to run it. If you see, this is the code is written in a very modular way, because input mode is given at the time of constructor, and we have all the different types of objects like input mode, output mode, color factory to create color, repository to store the slot strategy to select a slot, and then to create commands we have executor factory. So actual service will have all the required objects, and then in run what we do is depending on the input mode. Here it is I is an interface. You can see I is an interface. It can be uh, console input, in network input, anything. Take input. If at all it is not quit, we check a basic sanity command should not be empty, and then we get a command. This command is a command factory, where depending on the string it creates a command object. If at all it is not null, it means command is not valid. You use the output interface to print it, and then so on. So there is a service component. We have basic model. Whenever you are attempting a machine coding round, you need to see what are different models in the system. For example, in parking lot, you would have a slot, you would have color, you would have vehicle, and so on, right? So I kept a different component for model. Then we have output, input mode. We should also have exception handling in the project. There would be a different kinds of exceptions. Like what I did is I created a base exception, and all the exceptions should have a get message so that clients can know what is the exception. Like in general, what we have in real world projects, what will happen is we will have a get code and get message. Every exception will have a code and message to know why exception came, why did the exception even come. So I created a slots full exception, slots not found exception, and so on. Depending on these are different kinds of exception, and we have different commands. And to create a command, we have command factory, and we have main executor, main driver code, where we create a parking lot object and then just run it. So this is how a machine coding project looks like. We need to use different design patterns and make it very modular, and it should also be demoable. Let us see, it should be running. So enter input, maybe something like print. Do we have any print? It's not there. Book one KA slot booked. Okay. So is the status. So okay. So status print what are the slots and what happened. So when I booked a vehicle, like when I booked a vehicle with number one and the color, I think second attribute is color because I did KA. By default, it came as white. Maybe I will say something like vehicle number as 2 and then black. So now I do status. So yeah, okay, black is not a valid command. So book and then 3 and then maybe white book. Okay. So this is how we have booking thing. Then maybe if I take free first slot is already free. It says if I say free fifth slot, it says it's free, and then the slot is appropriately free. If I say quit, it will stop. So a machine coding code should be demoable. It should have different kinds of patterns. It should also have multi-threading in it. Like if at all there are two different threads, it should be thread safe. Like whenever, for example, here I'm using unordered maps in update entity, right? Before this, you should actually take a lock so that it becomes thread safe. So whenever you want to make the code thread safe, whenever you are updating entity, ensure that you are taking lock. For read, we need not take a lock as such. But so let me just create a summary of what are the things that we have read, and so let us create a summary. So first of all, we discussed about factory pattern, where depending on input, create different types of objects, right? So maybe I will create it in low line. That is one advantage. Separate object creation from application layer. That was one pattern. Then we have seen repository pattern. So create an interface to store objects and always use in-memory DB, in-memory data structure. Then we have said about interfaces should only depend on other interfaces, right? Search command depends on search interface and not its implementation class. Okay. Then what else did we learn? Let's see here. So then how to, maybe I will say how to write code for machine coding round. Right. First, come up with different models in the system. For example, plot, vehicle, color, and so on. Then see what are different components in the system. For example, repository, strategy. Strategy is also one thing. Maybe I'll write it in the top. So use strategy pattern. Separate decision making algo from application layer. When strategy to decide changes, application layer may not. That's the advantage of this pattern. So repository strategy, then what else? We would have models, we would have service, we would have basic what are different components. Yeah, so these are some components which are always there in every machine coding project. Always there. Maybe some more can be search, then strategy also depends on question only. Then we should have an exception component every time. Then input mode and output mode. Let me see. Repository strategy, search, service, output mode, input mode, exceptions, command. Yeah. So now we have come up with components, right? start with model component and slowly move towards service component, right? Like in parking lot, I would start with model, then I would go with input mode, output mode, then I would have a repository, and maybe I will come to service, and while implementing service, I will have command factory, so I will have command. While implementing book slot, I will need to have repository, so I will go there, I will implement this component, and slowly get a minimum demoable project, get minimum demoable project, because time is crucial in machine coding rounds, like 1 hour, 2 hours, it depends on the practice. So you need to, it's better to practice at least 2, 3 questions before going to machine coding round, because time might be a little less. Like it should also be demoable, right? Sometimes we make silly mistakes and it takes time to debug. So I chose Xcode, where I can keep breakpoints and debug different variables and thread stack where it is breaking and so on. So it depends on your IDE and how comfortable you are with the language. So choose language which is easy to debug and easy to write code quickly, and also have support for object-oriented concepts. Now, once you have the getting all project, add exception and make it thread safe. Then yeah. So I think this is how I have prepared for machine coding round, and uh, yeah, nowadays machine coding round is being asked in many companies like Rubrik, Flipkart, Crud, and many other companies. So I have followed this pattern, and yeah, I found machine coding rounds to be not that difficult after practicing for two three questions. So I hope you have enjoyed the video and learned how you can attempt a machine coding project. Yeah, see you on another video. Thank you.